Hello and welcome to my next video. I'm also trying the new microphone, so if you want, you can leave your comment whether you can hear me well and clear. I received a request yesterday. Actually, it is not the first request, and it was about how to code your discrete choice experiment, how to put what you see on the screen into values into some variables, tiny variables, or any other type of variables. And it is not the first request, and it already happened that some people asked me, what if I have 3 decision options, not 2 decision options, what I usually work with, and what if I use a different software, because the SDT tool for Qualtrics produces automatically these variables and you just need to restructure them and then to code the dummy variables based on what you have seen. In this event, I just want to show you how it works. So let's assume we have a very simple discrete choice experiment with the following attributes and levels. I just make them bold to see that these are the attributes and levels. And I suggested we have only 3 attributes: color, direction, and time. And for color, we have the levels red, blue, and green, direction left and right. And for the time, it is our scalable variable, would be 5 minutes, 10 minutes, 15 minutes, 20 minutes. And we want now to try to create a kind of dummy discrete choice experiment and dummy coding. So the decision scenario would look like this. For instance, which of these 3 options would you select? And we have here our attributes: color, direction, time, and finally the decision, because the person has to select one of the options. And let's assume that this person, he or she, received the 3 decision options to choose. It can be a car, it can be whatever object you're using. So we have decision option 1, 2, and 3, and here are the constellations of what people have seen. For decision option 1, it is red, right, and 5 minutes. For decision option 2, red left 15 minutes, and decision option 3, blue left and 10 minutes. And let's assume that the person has selected decision option 2. And this is our decision scenario 1. So if you ask people to make several decisions, it will be decision scenario 2, 3, 4, and so on. So decision scenario 2 could look like this. Let's assume here is our decision scenario 2. And the person will see here green, red, here's blue, and here we have, let's say, red, or again blue. And direction would stay the same. For the time, we will have here 15 minutes, 15 minutes, and let's say 5 minutes. Yeah, 10 minutes. Yeah, let's stay by 10 minutes. And the person has selected this option. So now, after you know what people have seen, you need to create dummies. Actually, it's very simple in coding. If you just think about the following, you need to depict whatever person has seen and what decision he or she has made. That is why for coding, you create a variable for each of these attributes and levels. So you need to show what were the attributes, what were the levels. Here comes a small tweak. It depends on how you run a discrete choice experiment. You can randomize the order of the attributes, or you can just leave them as they are and always start with color, then direction, then the time. If it is the case, then in coding, you have to also depict what was the first attribute people have seen. I assume that, okay, DC1 attribute, attribute 3, I think that's what exactly. So this is the beginning. So the first attribute, we need to show what people have seen. And DC attribute 1 was color. DC attribute 2 was direction. And attribute 3 was time. It can happen that in the next decision, you will have a different option. Let's say in here, you decided to swap these lines because you wanted to. Actually, the idea behind it that if you randomize it, you're randomizing for one participant. So he or she will always see the same direction of the attributes, but the next participant can see the decision differently. He or she may see first direction, then time, then color. It is made in order to avoid all the biases like ordering bias and so on that people read on the first line. Through the randomization of attributes, you can achieve it. So for this person, it will be color, direction, time. Then we have the next one. DC is decision scenario 1, DO, decision option 1, and red. Has this person seen red in the first decision scenario? And it is the case. So the person has seen red. So we put here a 1. And if a person has seen red in this decision option, we now talk only about this first decision option. he or she cannot see anything else because it will be, you can see only one of the levels in one decision option. So the others will be then automatically 0. So it's 0 for blue and 0 for green. I'll just make them bigger that you can read the text blue, and here we have the green. Okay, the next decision option is left and right. What has the person seen? And let's see what the person has seen. The person has seen right. So for the left, we code 0. For the right, we code 1. And the next attribute is time, and time is a scalable attribute, so we don't need to say whether the person has seen this or that attribute. We can just write a number. That's why we write here 5 minutes. Yeah. You can also code them as 1, 2, 3 because as an ordinal variable, but then you will need to multiply it by 5 because 2 means actually 10 and 3 means actually 15, but I do directly with the time. Now we talk about decision taken, and as you can see, was decision taken, yes or no? And it was a no. No, the person selected decision option 2. So this decision option is a 0. Now we move to the next one. Decision option 2. As you see, DS for decision scenario. This is the first decision the person has to make. Then decision option, the second option the person has seen, and red. Did he or she see red? Yes, it is the case. So we code here red as 1. And if red is 1, then automatically blue and green are zeros. So a 0 and a 0. Then we want to see what was the direction the person had seen. Let's see direction, left direction, right. We go here and see it was direction left. So for the right, we enter, for the left we enter 1, for the right we enter 0. Yeah, it was left that has been seen. Yes, it is left here. And scalable variable is time, and the person has seen the time of 15 minutes. So we add here 15. And whether the person has selected this option, she has. It is a 1. Because you can have only one decision. Some people add here none of the options. In this event, this all will be zeros and none of the options will be 1, but none of the options you don't need to code it. You'll just code decision for all of the 3 scenarios will be 0. But in this event, we have decision. We don't have the option, none of the options offered. We force people to select one of these 3. And we go to the next decision, option 3. Was it red, blue, or green? And it was blue. So red is then 0, blue is 1, and green is 0. Then we go for left and right, and let's see, the person has seen left. So we're coding left as a 1 and 0, right as a 0. And the time, 10 minutes. So we can put here 10 minutes. Can be the value if you use not time but money. It can be 10,000 euros or 10 years. And decision was 0. And then you copy these variables and continue coding the next decision scenario. In the next decision scenario will be already automatically decision scenario 0. So we just decision scenario 2. Let's see what I can do it automatically. It would be great if I could substitute it automatically. And we want to substitute DS1 with DS2. If it doesn't work, you'll have to do it manually. Okay, it worked. So look at this one. Now we have the decision scenario 2 here. And we start coding decision scenario 2. This is this decision scenario. So decision option 1, this is the one that we focus on, and it is green, right, in 15 minutes. So attributes will be the same because we didn't change the attribute. It will be the same. It was color. Then we had direction. Then we had time. Usually you don't change them within a person. You change it between people. So the next one can say different ordering. But anyway, so now I forgot what it was. Green, right, 15 minutes. So red is 0, blue is 0, green is 1. Then we had left and 15. Left is 1, right is then 0. Time is 15, and decision option, no, the person did not decide to pick this option. This is 0. Now we go to the next one, decision option blue, left 15 minutes. Red, no. Blue is 1, green is 0. Then left is 1, right is 0. Time is 15 minutes, and decision was not taken. And I make for you the last one, which is blue left 10 minutes and selected, which is red is 0, blue is 1, green is 0, left is 1, right is 0. And it was, what was it? 10 minutes, 10 minutes, and it was selected. And then you continue with the next one. And after you have all this data, you'll better understand why you need to restructure data for your analysis, because I already explained in one of my videos why do you need restructuring. Because in this form, you can hardly work with the data. And there will be, actually, you need here one more variable. We add here ID, and this is our first person, so ID is 111. The next person can see a different order and can see different decisions, but more or less this is how you code it. For each person will be separate coding. You can do it automatically. You can automate it in Excel. You can automate it in SPSS. Each time the person has seen something, just code it automatically to 1 or 0. That's what I do in my video on the fast analysis of the discrete choice experiment. Please watch it. And what else do I have to say? Exactly. Then you understand why do we need restructuring, because the next person will be 2 to 2, and the person may see a different order, direction, color, time. This would be the order of attributes the person has seen. And then again, you code all the values the person has seen in the first and second decision scenario. And if you want to work with data, you need to restructure them, because each of these decisions, actually, decision scenario, you can treat them as separate decisions. So you can theoretically introduce a different variable, which will be indexed, and you just put one below the other one. I don't want to show it here, not to confuse you, and anyway, I showed it already in one of the videos. So I hope it will help you with coding your data, and please watch my video on how to make restructuring. I make restructuring in SPSS, but you can do it in Excel and actually in any program. In SPSS, it goes like in a more automated way. In Excel, you might need your manual work in this one, but it's all possible. And after you have all the data coded, you can really analyze which of these variables, time, decision, and so on, which of these variables have impact on the final decision. And yeah, that's actually very, very simple. And as your decision is 0, 1, it means you prefer it or you do not prefer it. You run your logistic regression and you understand which of these items did have impact on the final decision. Which of the option the person has seen here had actually impact for the decision to take this option and to skip other options. I hope it is helpful. If you have questions, leave them below in the comments or drop me a message. Good luck with your research.